Hello everyone, it's July the 7th. Alright, we have a hard one, paint house. Well, let's take a look. Oh, this might be a new one. It is a new one. Nice. Okay. There is a row of M houses in a small city. Each house must be painted with one of the N colors. Some houses that have been painted last summer shall not be painted again. A neighborhood is a maximum group of continuous houses that are painted with the same color. For example, if we have these houses, it contains 5 neighborhoods: 1, 2, 2, 3, 3, 2, and 1, 1. Given an array of houses, which is this, an n by n matrix cost an integer target, where houses I is the color of the house I, and 0 if the house is not painted yet. Cost ij is the cost of painting the house I with the color j plus 1. Why j plus 1? Wait, what? Why j plus 1? Paint a house I with the color j plus 1. That's very interesting. Return the minimum cost of painting. It could be that the color has to be, the color has to be based on 1, and therefore it's j plus 1. Okay, that's fine. I know what it's doing. The minimum cost of painting all the remaining houses in such a way that there are exactly target neighborhoods. If it is not possible, return -1. Ooh wee. Madre mia. It is complicated. Let's see. So we have 5 houses. N, what's N? N is the number of colors, right? Number of colors. And target is 3. We want to have 3 neighborhoods. Okay, so the cost, let me draw it out. So it'll be M, so it'll be 5 by 2. 1, 2, 3, 4. 5 by 2. So the house 0, 1, 2, 3, 4. And the paint 1 and paint 2. So we have 1, 10, 10, 1, 10, 1, 1, 10, and 5, 1. So that's the cost. So it says for house number 0, the cost of a painting color 1 is 1, and the cost of painting color 2 is 10. Okay. So we can paint the houses of 1, 2, 2, 1, 2, 2, 1, 1. Right? 1, 2, 2, 1, 1. That give you 9. I see. 1, 2, 2, 1, 1. That's 3 neighborhoods. Okay. Example 2, example 3. M is 100, N is 20. So it's not too big. It's 1000% DP. You just need to figure out how to do the DP. Okay, so what is our question? Our question is the minimum cost of painting. So the minimum cost of painting, right? So we have some houses, and some houses that have painted last summer should not be painted. So we should only paint those that's 0, right? If a house is painted, some houses are painted. So then we want target 3. So it'll be 2, 2, 1, 2, 2, right? 2, 2, 1, 2, 2. Wow, who thought of this thing? Very smart. Originally already 4, so you cannot get a target 3. Okay, so we can only paint on a house that's a 0, alright? And we also need, is it possible that we produce all possible ways to produce the target number of neighborhoods? And then among them, we try to find, if we can, obtain. What we can do is to first check how many zeros are there. If there are already things that's painted, we can count how many neighborhoods is already there, right? We can count the number of neighborhoods. And the number of neighborhoods. N is 20, so at most 20 different colors. By checking this, we know at least, right? By checking the original, we know at least how many neighborhoods are already there. I'm looking for like this. If we just look at this, it's already 3, at least 3. And the target is 3, so there's actually no choice for us to do this one. This is deterministic. So we can do that just based on the colors that we have, right? Based on the color that's already there, then we can count how many neighborhoods. And if it's the same, then we'll just say paint the remaining with that number of targets. And that number of targets. And that number of targets. Like how many more neighborhoods we need to create by painting it. And then we can say, create 0, right, neighborhoods. And we can say create 1 neighborhood. Then what does it mean? You create 1 neighborhood. And if they are not close to each other. Like in this case, I was trying to, make it generic, right, for everything. But it just doesn't feel generic at the moment. So with restriction and without restriction, I know how many I can create, but with the restriction, and then we choose some, then it will not increase. Yeah, see, that is the thing. Or in this situation, I can say I have like something at the end. We can say a -1, right? And then we say you want to create 4. Target becomes 4, and we have 1 restriction. And even better, we can have restriction on both sides. So it's like we have restriction on both sides. -1, -1. So this is to use this painting strategy to get 4 overall, to get 4. Or like this to get 3, right? And in this case, we put a -1, so we say, okay, I want this to give me what? Give me 1, right? This to give me 1 and 1. Yes, like if we don't consider this, right? If we don't consider this just with, let's say for -1 and 0, we want to create 1. Nah, that's not true, because if you want to create a 1, you can always create the same thing. How do I do this? No idea at the moment. Let's think. What's the similarity between these two situations? Does it just have restrictions, right? I was trying to have restrictions here, but it doesn't really work. It doesn't really work. So maybe we should consider this separately, with or without restrictions. Like if one has, this basically has restrictions, right? And we have a color here. So, I mean, reason it. There's so many different situations. Why don't we try to solve this one? Nah, we don't worry about it. This is too complicated. Let's try to solve this one. Without restriction, how would you do it if we don't have restriction? Well, if we don't have restriction, like I said, how long is the houses? Is m equals cost the length, yeah, and m is smaller than 100, so I have smaller than 100 houses. Okay, I have smaller than 100 houses, smaller than 100 houses, and I want to find, and I have a target. Okay, so I have some array of values and I have a target. I want to find out, however the target is, we can just go color, because target will be smaller than m, right? Target is smaller than m. And we can say if there are more targets, we can roll around, right? We can roll around. There are just so many different ways to do this. It's not reasonable. And so we can do it with only 2 colors, right? We can do it with only 2 colors. Or maybe you can say, let's try to fill this with the cheapest possible. And then as we go through, so that's the minimum cost, right? That's the minimum cost. And we say, okay, and then we see how many targets there are. And then we see, okay, it's like for this, for example, if we go cheapest, that's 1, 2, 2, 1, 2. That's 4, right? The target right now is 4. Now we need to reduce to 3, which means I can. How do you know we can change something to make it into only 3? I don't know, man. Okay, so I can say we want a 3. We can label it A, B, C, right? That's one way to label it. What else? So we can say, okay, how about A, B, B, C, C? How about A, B, 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 C? Yeah, it will have like this. And then I can now go even more, and then we can grow A, so it'd be A, B, B, C, A, B, C. So we have 1, 2, 3, 4, 5. 5 different scenarios to get. So basically, we'll have the target, right? So we have ABC, however much target is, and target is, so target can go all the way to 100, that's fine. And we just go with that, and then we can try to fill. If we cannot fill, then we just, the last one, and then we can reduce the last one, increase the middle one, reduce the middle one, increase the first one. And that shall cover all possible scenarios, right? That shall cover all possible scenarios. What are you thinking? Then once we have this, then we can try to fill the numbers in. And if we have 3 colors, we can do 3 colors. We cannot do more, right? We cannot do more. So like if target is 3, then at most we pick 3 colors. But 2 colors can work as well, right? 2 colors can work because, yeah, any 2 colors will work. 1 color doesn't work, but 2 color will work. We can have, but then we have to also consider on a cost. We try to make it as cheap as possible. Okay, so we have all these patterns. Then we generate the cheapest one, and then we try to see which pattern it fits. That's 1, 2, 2, 1, 2. So that's basically A, B, B, C, D, right? That's A, B, B, C, D. And then we're trying to see how much we need to change. Okay. And if we compare to the first pattern, we need to change 2 positions. So both these 2 need to become 1. And then we can calculate the cost. And then the second one, we only need to change 1, the last one. The third one, we need to change 2. The fourth one, we need to change B, B, C, or I should change 3. And the last one, we need to change 4, right? So, yeah, maybe that's the way to handle it, is write all of the patterns and then compare to see if there's a pattern that match. That means we have found the smallest. If not matched, then we try to see how much we need to change. And as we read through the pattern, we know what each letter represents, right? We can say, okay, A represents 1, B is 2. So if we need to change it to a C, then we know what C stands for. But the fear is sometimes changing 2 letters, right? It could happen, right? You change 2 letters, it will give you a better result. It's possible. You need to change 2 letters. So, I don't know. But we're still trying from the minimum. Try to fit every single one. So from the minimum, we're trying to fit every single one. And we can compute, see how difficult, how much more cost it will take. But it could be that we can use a different set of numbers. Right? Yeah, I think I can construct a counterexample to this. Then you are saying it's like the minimum cost, but the end of it's like super high, right? It's possible if at the end it's super high, and then maybe we can swap. Hold on. So what we're saying is if we go to minimum, right, and then we try to find all the patterns. Okay, yeah, it's fine. We go to minimum, and then we try to go through all the patterns with a minimum. We have the minimum. We have a pattern, right, and then we try to fit all the patterns that we have, and each one will tell me, okay, how much I need to change, and let's say at one pattern, we'll say if you switch to another pattern, it will actually produce lower, even though it's never minimum in any one of them. If that's possible, so let's say there's a pattern, right? And then none of them are minimum, but overall, that gives us the smallest value. What does that say? And then we have the minimum, then give us something bigger. Yeah, it is possible. And then just like for those, I have to switch. Yeah, I can definitely see that happen. If you can definitely see that happen, then what? How do I avoid that? Yeah, let's say the minimum is all different. Okay? And then you want to fit, you have to change all of them. Yeah, it is possible. You have to change all of them based on what you have already. And they could be very expensive to make the change. I don't know. If you can, I can search. Say like I'm at I, and I have from the start to I minus 1, they fit the pattern. Okay, they fit. Well, it's not hard to say. What do you mean by they fit the pattern? There's no pattern, right? It's just the target. We can say how many targets we have in this situation. So in this situation, I say I have, doesn't matter, a certain amount of target. So DP will say, if you have 5 to fill, let's say you filled 4, okay? Now you filled 4. I want to see what should be the 5th one to fill. Well, in order to know what the fifth one need to fill, well, the 5th one is just one of the colors, right? We can fill one of the colors. We can say, okay, we're gonna fit one color, and if it doesn't work, we'll fit the other color. If it doesn't work, if the third color doesn't work, and one of the color will work, and I can compute current, then we move on. So this is more like backtracking. We just pick a color for the first one. We don't care. And the second one, we pick a color. Third one, we pick a color. If one, we just go all the way down to the end, and then we say, okay, this gives a result. And then we try to pick another one, and then we backtrack in the front. We try to pick another number, another color, and if it works, it doesn't work, and we go back. Now, that one will work. It's like going through all possibilities. But we don't have to go through all of them because we have a target requirements, right? We have a target requirements. And we can say at a certain step, what's the current number of targets, right? Because it's only associated with the one right in front of you. Yeah. Okay. So I think this will work for this situation. If we just do a DFS search with backtracking. How about this? Well, it'll be the same. It's just these are pre-filled, right? Like I can say I want 1, fine, and then we say, oh, this one is filled. 2, then we have 2 targets, and then 1, oh, we have 3 targets, and then 2, oh, we have 4 targets. Wrong, reverse back. So this one cannot be 1, so this has to be 2, right? And then 2, that's still 1. That's 2 targets, 3 targets, and here I can say, okay, I want to go 1, and then boom, 4, backtrack, 2, that's it. I'm going to try that, but not confident on the time complexity because it could be, all right, it could be too slow. Never know, but gotta try, man, gotta try. Okay. So tomorrow. Okay. Let's see. All right, so what I'm gonna do is we call it DFS. Okay, so I need index, num target. Currently we have, and the cost, right? The cost, and we will say this one. Do not return anything because I am going to have something called self.res equals math.inf. Okay, so we're going to go math. Why did I think I deleted initially. Okay, so with this, what do we do? So index position, and we're trying to say num target. Okay, so what do we say? What's the end condition? The end condition is, we can actually say n equals len houses. Oh, we have n. Oh, we have m. So we can say, what's m? M is the number of houses. So if index, right? If index is equal to m, that means we go to the end. Then we say self.res equals minimum self.res and a cost. Boom, done. Return. Else. Right? So we're at a position that we need to check. And we say if houses index is not equal to 0, right? Now house index is not equal to 0, then what we need to check is the previous one to see, okay, and there's another one is if num_target is larger than target, then we'll return failed. Can't do it, right? Can do it. It has to be equal. Can do it. Otherwise, if this equal to m and num_target is equal to target, both has to, then we do this, right? Otherwise, if it's larger than target, yeah, or we say index is equal to m and num_target is smaller than target. All right, so these are conditions that we say fail. These are failed conditions. This is a successful condition, and not that is going to be index is smaller than m and target num is smaller than target. Okay, so if we have a house, then we need to check compared to the previous one. We say if houses index is not equal to houses index minus 1. Now it's very important to say if index is equal to 0 or larger than 0, then when we go to the next one, we always add 1. Right? That's the first one, we always add 1. Then we just call it DFS. Okay? Because this one, we can't do much. Right? We cannot do much because it's already filled. So we just go to the next one, we say index plus 1. Num_target plus 1, because the current one is different from the previous one, or the current one is the start, so it has to plus 1. And the cost does not change, right? Because the index, we have it right now, right? This one, we have it, so we don't have to paint it. So that's that. So if this or else, what's else? Else is index is larger than 0 and index is equal to the previous. So if it's equal to the previous, then we just do DFS index plus 1. We don't change target and there's no cost. That's that, right? Okay, so this is the two situations when we have already painted, else we have not painted. Then we have to go through all possible ways to paint it. So we say for what? Let's say for j, for I in range 1 to n plus 1. Okay, so that is our colors. Right, the I is our colors. And what do we say? We can say we can pick the current color. Okay, so we say and backtrack, actually, because I would change it all the time, so it doesn't really. Let me see if it matters. Yeah, so when we return, we have to reset it to 0. Otherwise, it's fine. So we just say houses index is equal to I, right? Equal to this color. Then we say if index is 0 or houses index is not equal to houses index minus 1 is the same, then DFS index plus 1, num target plus 1, cost plus, what do we plus? We have to plus the cost of the current house and the current paint. It's going to be I minus 1, right? So we do that. Else, then we say DFS, index plus 1, num target don't plus 1, because we do not increase the target, but we still incur the cost, right? And then we'll for blah 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 blah. We'll go through all of them. When we go through all of them and we will go back, we have to reset this to 0. This is the backtrack. And once we're done, we can return. And we're gonna call it DFS from 0, right? Num target, I don't know, 0, because at the beginning we don't have any target. Hold on. Do we have target at the beginning? What is the number of target for 0? For 0, it should be 1 target already, right? Yeah, we have the first one. No. If you think about it, I plus 1. That's after this. This is the new, right? So the num target when you pass in is before I consider the current index. So it should be 0. Cost initially is 0. So we do that and we try to return self.res. All right, let's see. Let's see if we have this one right. So we have all of these. Madre mia. Never had so many arguments before. So this is a good one. And give us, yeah, we have 3 test cases. Minus 1. Ooh wee. So return res if self.res is not equal to math.inf, else minus 1. All right, so we now need to, I think we can do this. Watch me. Yeah, okay, watch this. Okay, and we can say v go all the way to this, delete. Okay, and then we do this. Nice. Very nice. Look at that. The magic of Vim. Oh, that's an interesting thing I found. So I was on the Kubernetes a pod, and I would try to edit something. There's no V there. There's no Vim, no nano, no nothing. The only thing I can do to write stuff into the pod is a cat. That's kind of disappointing, but it's understandable. You're not supposed to write anything there. Come on, right? But I need to do some experiments, so I have to write something there, which is against the use case. But it's fine. Mean cost. All right, let's see. Ooh, nah. Int is not subscribable. What the hell? What's that? No. Cost. Wait, what was wrong? Oh, the const. Cost. Not sure. Oh, I use the same thing. Damn. Current cost. Okay. No panic, no panic. We just need to, yeah, these are the current costs, and this is current cost. All right, this looks promising. At least we passed all these test cases. All right, let's go. Either we are right or we time out. 100. I still start with timeout. Ew, it's not giving me good outlook. We might have a wrong answer. Or timeout. Time limit. How many did we succeed? I only go through 9. There's 60. What is this? My lord. Huh. It didn't work, huh? Maybe, I don't know. Yeah, we can try. Say, let's cache it. It'll run. No trouble. We'll run this. Yeah, do you want to try it here? No, I don't want to try it here. Because if it doesn't work, then the laptop will freeze. I don't want to try. I want to try it there. Alright, let's see if that is the fix. That is the fix. Go again. Come on. Come on. Give me some. Give me some. Give me some. You gotta be kidding me. Well, actually, it's not kidding me. This is a different problem. This is a logic issue. How many did we go through? 31. We go through half. We went through half. So that's the initial trouble. I mean, we can. I'll put this on my test case. So this one's supposed to be, dear Lord. Okay. Yeah, this is gonna turn into a trial and error. Honestly, it's fine. I'm not too worried about it because it's a tough problem. Come on. They work. Expected 24. Output 26. Oh, shoot. There you go. Output 26, that's 24. We can run and then find out it did not work for the last one. Okay. Okay. What if we don't cache? Then it works. So we kind of know what happens right there. The last, I know what the last. So num target index and the pre-color. Okay. So when we go in, pre-color is -1. We don't have a pre-color. And then we just need to pass a pre-color. So what is the pre-color? So like at a current state, I have index, num target, current cost, and I need a pre-color. Right? I need a pre-color. I mean, in fact, current cost is not one of the things. It's just, let's put it there, which is fine. We just need to do the pre-color, which is houses index. That is the pre-color, right? That's the pre-color. It's like, and my current one, what is the pre-color? Now, when we do this, we might be tempted because the pre-color is just, I can call that, right? I can call that. Alright, so I can just do pre-color. I already passed it in, might as well. Alright, and then this is going to be the pre-color. And then current is this. And then I can just say if I is not equal to, oh, okay, let's not do I, let's do C to indicate its color. Right, so if C is not equal to pre-color, then blah blah blah, we're passing C. C is the current color, so it becomes a pre-color. Otherwise, it's going to be this. And we roll back. Now we run it. Oh, what the hell? No, it's not right. Oh man, are you saying the entire thing has to be the state? Caching is not working, right? Oh. Man. But I want to cache. If we don't cache, we run into trouble. How do we cache the current state? I have a wild idea. I have a wild idea. House is only 100. We can create a tuple of size 100. Like, right? Right? That's the state. Right? We need to cache, but at the same time, we can, like, the state has to be exact. What are you saying? What I'm saying is we're gonna pass in a thing, a tuple. Okay? We're gonna pass in a tuple, which is we'll call it state. Okay? The tuple is a state. Can we do this smartly? The colors is most 20. Okay? Which means each one at most is 20. I know what you're thinking, but I doubt we can use bitmap for this. But think about it, it's just the English letters. It's English letters. It's a string. Right? It's just a string. We'll do a state. Okay? We do a state. That's going to be a string. So we don't have to do any of these. We don't have to change any of this. So we don't have this. It's just houses index minus 1. We'll do this exactly how it is supposed to be. But we're going to do a state. Okay? And we're going to say state plus char char. Houses index, right? Plus, is it 96? Let me double check. I think it is. Ord A 97. 96. Because the color is 1 based. Right? So we can, if it's like, say we say char 96 plus 1, that will give us A. So that's how we get a state. So we have state here. We have state here. Everything is just there. I mean, we need it. And now we don't have pre-color. Come on. We don't do pre-color. Houses index minus 1. And this is cost. Yeah, well, fine. It's just not C. It's going to be char C, that's the current color, plus 96. No, state plus this. State plus this. And then this is state plus char C plus 96. And we'll start with an empty string. Run it? You gotta be kidding me. No, it's not right. Ooh. Now this one goes to infinity. What the hell? What the hell? Not how I expect it to be. I thought with a state will be right. No. Huh? How? Why would this not be right? It's like if without state, and we're correct. Wait, this is strange. We add the state, and it's no longer right. The state's not doing anything. Huh. Will be interesting to see. Expected 24. And we want it's M, N, wait, hold on, M, N, target. So the target is 6. We want 6 targets. Right? M, N, full color. Full color. 6 target. 1, 2, 3, 4, 5, 6. Correct. Oh, it's not I. How do we even get I? Why don't you return error? That should be C. Yeah. So this is correct. But once we add this, well, it should still be correct. But we will run into issue with this. Yep. We'll run into issue with this. So how about not? Because let's try it again. Pre-color. It's fine. Then we just pre-color just houses index at the pre-color. There could be like, because earlier I have the error on, it was not C, it was I, so I made a mistake. So the state is only the last one. Okay, and we run it. Oh my god. It passes still, but it took a gazillion amount of time. 1.9 seconds. Oh, and of course, this is not this. This is -1. Pre-color. Man, I'm not sure. We could time out again. All right, if we time out again, I'm gonna check the answer. I have no clue. What I can do, if I can reduce, which I feel like I can, like the cost. I can calculate the cost. I don't have to put a cost along the way. I can also do this. But then, like in this case, if we don't cache, there's just no hope. Right? If we don't cache, there's no hope. Cache at least helps a little bit. And I just realized this is a side effect. Right? This is a side effect. I'm not sure. And for this to work, we can modify, if we modify that, can we? Can we modify? No, we are modifying. Look at that. We are modifying. So why are we keeping num target and, oh, we keep num target. We don't need to keep num target. We can calculate, right? We're going to do group by, and then that's how many groups. Okay, let me save this code. And let's submit this for now. We know it works. It might work slowly, but it works. Okay, this one works. We can try this. It will take a while, but it works. It take a while. It works. We see how lenient it is. If it is lenient, we might get it. If it's not lenient, we got timeout again. Seems like we got timeout again. Yep, we got timeout again. I can see how many we have. 30. So that's not the case. Okay, let's see if we can remove these because we don't really need, right? We don't really need because we can compute, right? The num target can say we can do from iter tools import group by, and we can just say, I don't know, num target is equal to group by houses. Oof, houses. Oh man. Oh, I know. Houses. Oh, hold on. Can I even cache this? So we're looking at index. I haven't done anything yet, right? So we say group by this, and then for can we lens this directly? I'm not sure. Okay, from iter tools import group by. Can I do len? I don't think len group by works because it returns. Nah. Group by a dot size? I don't think so. No. How about list group by a this? This works, so we can turn into a list. Wait, hold on. Hmm? All right, let's see if it works. So you can just do len list group by. Okay, so we got another target and the cost. How do we find the cost? We will not do this. We'll have a copy. Houses underscore equal to houses. Okay, so here all the houses will be houses underscore. Okay, all of these will be underscore. So we can calculate a cost here. I'm going to say total cost equal to 0, right? And then for I in range, I don't know, M, right? I just go through every one of them. If houses, if not houses I, right, which means it doesn't have color, then total costs plus equal to houses I. Houses I what? Houses I, that's the color, so the cost I, houses I is the color minus 1, right? So it's the total cost. If it's not, then we do that. Which we probably can just say sum this, right, for I in range M, if not houses I, and then total cost. Okay. And then what you need to have the previous. So we don't need this, nor do we need this, and we don't need this, and we don't need this. Just the last color and the current index. I'm not sure. I have to give this a shot. Yeah, it doesn't seem, I don't know. Just the index and the last color. Honestly, this doesn't feel right. We can run it. Ay. Oh, that's because of this. Yeah, okay, doesn't, not right. We need something out there. And what? One of those things made a difference. The number of targets or the current cost? This is... Hmm. Wow, we never reached the end? How is that possible? Curious. Have we even reached here? No, we never reach here. Huh. What is this? Video 1, 2. Huh. Hold on. These two, they're exactly the same. What's the point of previous color? I don't understand. It is change the num target, but because I can calculate it, so it's fine. Yeah, it doesn't represent a current state. That's why. Current state. Hmm. Alright, I think it's time to give up. Hint, hint, hint. DP. 3-level DP, okay. K neighborhoods in the first, so we do have to have neighborhoods. Okay, neighborhoods. And ith house is printed in color J. Okay, so right, basically just that. So this is the good state. Let's use the good state. Okay, so this is a good state, and everything passes. It just took a while for everything to pass. So we just remove one of them. Okay, so we don't want the cost. If we don't want a cost, then we have to calculate the cost ourselves at the end, which is fine. We have the I have to use the trick. It's okay. So we say cost equals the sum of I in range M if not house is I, right? And then we say cost I houses I minus 1. And then we just remove that, remove this entire thing, and remove this entire thing. And of course we remove this num targets, run it. That's interesting. Total cost is 0. Oh, I forgot to change. Dude. Nope. But these are the 3 things. We captured these 3 things. And we have some is correct, some is wrong. The first one is not right. The result is just way too big. Can I print houses? 11121. Isn't that one of the results? 12211, 122. Where's 12211? You didn't even give me 12211. What about 1, 2? Don't know, man. So initial is 0. So on here, we're seeing a range of 1. Facing 1 and 2, so I set it to 1. And go to the next one. Set it to 1, go to the next one, set it to 1, go to the next one, set it to 1. The next one, boom, fail. Right, so I come back, set it to 2. Okay. So now equal to, and then we get a result. And then boom, go back. Have a 1, 1, 2. One, 1, 2, 2, 1, right? Because 1, 1, 1, 2 and a 1, 1, 2, 2 is the same, but they have a different cost. That's why they're different. But this is exactly what the hint says. K neighborhoods, right, which is this, in the first I houses, and the I house is painted with color J. Well, this is another I house. That's the only difference. And I see why this one doesn't work, because 1, 1, 2, when we go to 2, 1, 2, how about 1? I already have 1. Okay, change my mind. So I try the hint, which means at a current position, which is 2, and that would be the same, right? The current is 2, and the previous we have 2 neighborhoods. If 1, 1, 2, 2 is also 2 previously 2 neighborhoods. Cost. Want to find a minimum. What do I say? Just at a certain point, I will do this, get my cost. What if the cost is, whether the current cost is lower, then I do it again. So we do have to pull the cost as well. Okay. That's okay. That's okay. Now I want to say, okay, IJK. I is the house. J is the Yeah, cash I cannot do. Like I have to keep going. It's probably just because the cost is going to be lower. If we do like 1, 1, you can see 1, 1, 2. Yeah, 2, 1, and then 1, 1, 2, 2, 1, 1, 1, 2. Like at this 1, the cost will be, when we choose 2, the cost will be lower. But I just will never do it because it's already tried it. So I do have house. This is a minimum cost, right? And that number of targets with color. So n by n, where the inside is number of neighborhoods, and at most will be m neighborhoods. So the current cost, say math.inf times m, right? And it's the inner, and for this in range n, and this for this in range m. Okay, so we say dpijk is the minimum cost of painting I houses with the ith house having color J. Oh, you gotta be kidding me. Color J. So plus 1. Having color J and K and K neighborhoods. Okay, and oh man. We can still use this, but just don't cache it, right? So we're gonna call it I, J, and K. Okay. If K is larger than targets, or I is equal to M and K is smaller, then it is return. If I is equal to M and K is equal to target, then I can put costs actually. It's fine because we're not using costs. Then we can say current cost. Right, and then there's no this thing. It's dp I j k. Yeah, it doesn't really matter. So when we come here, right, and the current cost is always the smallest, so we just do a just do this. And if this, we just return. Otherwise, the houses on the I is 0, and if houses I is not equal to houses I minus 1, okay, then so we go to the next cost, right? It should be when we go to the next cost, so we'll decide not to visit it if I have already figured out what the next cost is. But, oh man, but how do we, and these two methods that just don't coincide very well. The next cost is already there, then I find it. Now I have to change my mindset. This is different. It's like the current costs need to be determined by the next cost. You know what? No, let's. Can we just write K neighborhoods? So I'm going to say I a range of this, okay, J range of this, and then the first house, right? And if it is, then we move on. Okay, let's ditch this. Let's just, I don't even know what to do. So I in range M, right? One house at a time. So for the first house, if houses I, which means this house has already been painted, right? If the house has already been painted, then we say, what do we say? How many neighborhoods? No, I realize this has to be n plus 1 as well. How many neighborhoods? Well, we say dp. Give us the current cost. Well, it will be dpi. So if I equal to 0, for houses, hold on. If houses I, it's already printed. If I equal to 0 or houses I is not equal to houses I minus 1, right? So just the current house and the previous house are not the same color. Now, if that's the case, but as it's already painted, then the current one is dpi, the current house, with color is going to be houses I, right? The current color, neighborhoods. How many neighborhoods do we have? So it has to be the previous neighborhood plus 1. What is the previous neighborhood? You gotta be kidding me. I don't know. Neighborhoods. we need to keep a track of the neighborhood. Right? So if this is the case, then neighborhood plus equal 1, right? Because we always have a new neighborhood, then this neighborhood shall equal to dpi houses, because they're not the same. I minus 1 is the previous. Oh, I minus 1. Alright, that's the previous house out of this color. Oh, we don't have I minus 1. Oh my god. Oh lordy. Okay, we can do plus 1, so we don't have to worry about this. And then this will be 1 to m plus 1. For houses, goes minus 1 plus houses. Okay. Then I from here, if houses I is not equal to the previous one, neighborhood plus 1. And then the dpi, this is the current, shall equal to, and then the thing in the first row and the first column shall all be 0, because it doesn't exist, right? Yeah, so what he's saying is a 0 neighborhood. So like 0 for j in range n, for k in range m, right? Let's say dp0, which is doesn't exist. This is something doesn't exist. And that's the only thing that we will actually query, because I minus 1. So dp0 jk, I say this shall be 0. Okay, I say this shall be 0. And then when I query dpi minus 1, I can do that. And it houses I minus 1, that's the cover. And then neighborhood minus 1, it'll be the same, right? Because if the current house is painted, then the cost is going to be the same, right? Like I'm not painting anything, I'm not changing anything. It would just be the same. else is they're not the same, right? If they're not the same, so the current house and the previous house is not the same, but I don't painted it. I don't paint it, so the cost is the same. But now if they are the same, the neighborhood doesn't change. And we say dp, so it will be the same thing, right? But this one will equal to the same neighborhood. All right? It will be the same neighborhood because neighborhood doesn't change. Else, then we can take a j in range 1 to this. Okay, we have different colors. And then we say the current color is j. And then we just say so the house is 0, then we don't have color. So we say if j is the current color, not equal to houses I minus 1. Okay? If that's the case, the neighborhood plus equal 1. Alright? Then dp I, and actually houses I will equal to j. Right? And then if j is not equal to the previous one, then dp this one will be j. And current neighbor shall equal to the minimum dpi j neighbor, and our previous cost, which is its houses, j minus 1, neighbor minus 1, the previous neighbor, right, plus our cost is going to be ith house and j minus 1. This is the previous cost, the minimum cost, with I minus 1 with the color j minus 1, no, it's I minus 1. The previous color, and then the number of neighborhoods plus the current one. Okay. Else, if j is equal to, right, then the neighborhood number doesn't change. And we say dpi j neighbor shall equal to the minimum, so still the same, but the number of neighbors don't change. Equal to previous will be the same neighbor, right? We have the same neighbor is the previous color, it is the same as j, and then this is the j minus 1. All right, so we'll go through this. How for I will go through all the j's. All right, so j is this, or j is the next one, and then we move on to the next. But how do we track the number of neighbors that we have? There's no such a thing as backtracking. We're just forward going on. Yeah, how do I know the neighbors? I'm confused. We shall go through all the neighbors as well. It shall be the eyes with this color, and then we shall have different neighbors. If it's one neighbor, one neighborhood, what's the cost? Two neighborhood, what's the cost? Three neighborhood, what's the cost? So in that sense, I'd rather do this. This, I think, should be a dictionary. Right? I'll go with default dict. Then we don't need this. We don't need neighbors. And then for I, right? Then I want to know. So I want to find out DPI houses I, right? Which is I appended with this. I want to find all possible neighbors. And then we go to the previous one to find all of its possible neighbors. And all of its possible neighbors. If it doesn't have any neighbor, well, we shall have zero neighbor. Maybe we should. Maybe we should be like this. I in range M, J in range N. Right, we say DP IJ zero neighbor cost is 0. So now, once we hit anything, then we can just say for neighbors. For K in DP, I minus 1, houses, I minus 1, color, right? So with this and the color, oh man. Maybe this one should be 0. So we're looking at DP and houses will be 0. It will be 0, 0, right? So we're trying to find out this is the previous one have all of these different neighborhoods, right? So for k in these neighborhoods, and for me, because it's different, so it'll be k plus 1 shall equal to dp this one k. Else, same thing for k in the previous one, and they're the same, so the neighborhood is the same. And for this one is the same, so for j and if houses I, it has a color. And then I want to know the previous color. Hold on. So the current house is painted. So I want to know the previous house's color. How do I know the previous, all possible previous house's color? Which is just I minus 1. So if we go dp I minus 1, this gives me a list of dictionaries, right? And then indices of the list is going to be the color, right? Then we're just going to say for j, right? For j in range n, and that's just the color. That's the previous house's color. Then we say if houses I is equal to j, so the two houses color is the same, then we say so the two houses color is the same. Okay. Then we say for k in, this is the previous one, j's color, if all have k of these, simply say for all of them the dp, because they're the same, so we can just say dpj, the current color, k, that's because they're the same, so the neighborhood doesn't change, equals to this j, right? And then we say else if current house color is not equal to the previous one, right? If it's not equal to the previous one, then for k in dp I minus 1, still j, because that's the previous color, right? So the previous one was the previous one, we have a bunch of color for the previous one, and if each color is going to be a dictionary, and then we just go through this dictionary, which is the previous k, number of neighborhoods. So we say dp I, no, it's not j, it's we houses I, so this color with current neighborhoods, but I have to go plus 1 because we're different, so we increase, equal to more neighborhoods, but the cost is the same because we don't have to add anything. So that's that, and else, right? And then we will do basically the same thing here. And then for j in all the colors, right? Actually, in all the colors, my bad. So we have 1 to the plus 1. And then 1 to n plus 1, that's all the colors. So for all the colors, and then houses I is empty, so we need to put this color, right? So this is this is the previous color, okay? The previous color. Now we have the current color, right? And we also need the previous color, okay? So what you're saying is we should have the previous color as well. So for the previous color, so for pj in range 1 to n plus 1, that's the previous color. And then for current color, also in this, right? And we say if previous color is equal to current color, then for this in previous color, right? In previous color, we say current color k equal to previous color plus cost I current color minus 1. And then that should be the minimum of dp I cj current color and k. Previous color plus the cost of painting a current color. That's if it's the same. The same just means the neighborhood count doesn't change. Right? Else, if they're not the same, so the previous color and the current color are not the same, then for k in the previous color, right? In the previous color, we have the current, that should be k plus 1, because they're not the same, so we're actually increasing. Right? We're increasing, so plus 1. And then that will be the previous plus the current. Yes. Okay, so this is for previous color, current color. If the color is the same, if the color is not the same. Yeah, and then we keep going until the end. Then we just gonna return wait, what happened? Oh, I forgot this. So I'm gonna return dp m n target. Oh, yeah. I'm not sure. Index out of range. Is it this? I don't think so. Wait, which one? Out of range. I is 5. 1, 2, 3, 4, 5. That is fine. DPI. I did n plus 1. Oh, technically, this has to be n plus 1. Oh, it's cost. I see. Cost needs to be minus 1. The heck? Oh. Minimum of the previous one. Plus the cost. How about lambda mass science? How about that? The result is 3. Doesn't sound right, huh? Mm. Hmm. one neighborhood or 0 neighborhood. How do we handle the neighborhoods? The initial state, neighborhood of the initial state. Well, the initial state I have yeah, I think this should be fine. And then what we have is current. I have a color. Then these are the previous color, right? And we say if the current color equals the previous color, then we want to find all possible that's in the previous color. Now, if we are to start, all possible previous color probably just 0, right? If this is 0, previous color, you know what? Let's not do this. And we simply say we want to find how many do we have in the previous. Then we just say if not dp I minus 1j, which means there's no previous state. Then we just say dp I j I'm the start. 1, right? One neighborhood causes 0. Else, if we have, then we do this. It'll be the same. Same as here. We say if not dp I minus 1j, previous is not, then and the previous color. If I'm the first one, that doesn't really matter, right? So honestly, this should actually be on the top, right? So this is the previous color, and it doesn't really matter, right? So if we go through all the previous colors, and if there's nothing in the previous color, then the current one, if it has, if it hasn't, maybe I'll redo this. Let's say for previous color in range 1 to m plus 1. Okay, that's the previous color. The current I, but previous color. And then we say if not dp I minus 1 pj. Right? If there's nothing, the previous color is nothing. So my current one is the first one that can form a neighborhood. Then I say if houses I, which will have color, then dp I then we say for current j in range 1 and plus 1, right? We can do all of them. And then current j 1 equals to 0. Right? It's a special case where there's the previous color, right? And if previous color is no previous color, current is the first, right? So it's a current is the first, and then if current one houses I, right, which is we can see it houses I, then in that case we say doesn't matter what color I pick. I can pick, actually no, if houses I I cannot pick any color. There's only one color I can pick, which is houses I. Because that's just my color. I cannot do anything. Else, if I don't have, then I'm free, right? And for current j in range 1 to n plus 1, simply say dp I current color 1, because I'm the first one, equals cost cj minus 1, no, I minus 1, and cj minus 1. Okay? Else, if we have previous color, so if we have previous color, we have previous neighborhoods, then we should build upon the previous neighborhoods. Then we just say for previous k in dp I minus 1, previous color, right? So for previous, and then again, if houses I, if I have the current color, right? If I have the current color, then we can compare the two colors, right? If we can just say if this one is equal to pj, right? No. Then we say if houses I is equal to pj. So the two are the same, right? Then if the two are the same, and we have, so I don't need to paint, right? Right now I don't need to paint, and they're the same. We say dpi houses I, that's the current color, and then neighborhood. We don't change. There's no change in neighborhood because it's the same. So equal to dp I minus 1, previous color and previous neighborhood. Else, if it's not the same, right, then we just say pk plus 1, right, because the current neighborhood is the previous neighborhood plus 1, equal to the previous color, the previous one, the previous color, and the previous neighborhood, because I don't have to add anything to it. So that's if houses. Else, if there's no house, right, if there's no color, then I need to paint. So now we say for current color in range 1 to n plus 1, right? Again, now we say if cj is equal to pj, so the two colors are the same, then we say dpi current color previous neighborhood, previous count, right? Because they're the same. So the number of neighborhoods doesn't go up, but we can do minimum dpi cj this, and then dpi minus 1 pj previous color pk plus cost I minus 1 and current color minus 1. Else, if they're not the same, okay? If they're not the same, then be plus 1. Previous neighborhood plus 1 equals minimum plus 1, and then that's the previous one plus the current one. Okay. All right, let's try this. Oh my god. 14. Why is it still not right? Can I just go dict this? Yeah. What the hell? No, I don't think it should be M is the M with different colors. This is just saying I'll print that color. So no, it should be the minimum J for J in range 1 to n plus 1. Oh, this looks promising. Oh God. Oh God. It's not promising at all. Yeah, this one doesn't pass. How? I got result 5. Sheesh. Maybe I need to go, I don't know. I need to go minimum as well. I don't know. It's not right. That was 3 plus 1. Nope. Wow, it's 2.5 hours. I still couldn't figure this out. I feel I'm so close. So close. No, I don't think it's minimum here. I think it's just we shall follow the previous one. Previous color, right? And the two colors are the same, and I'm not paying anything because it's already painted. Let's analyze this. We can analyze this. Okay, what do we see? Answer is 11. I have 11, which is 3, right? And then if we look at 3, we need to go J, which is the last one. J, the last one, IJ is 1. That's why I got here, but I cannot take it. This I cannot take. Oh, shoot. I think I know why. This is fine, right? And then for PK, for previous K, and then that must be valid. And then we say L if PK plus 1 is smaller or equal to target. Then we do it. L if PK plus 1 is smaller or equal to target. All right, otherwise we don't do it. What? You say 5, I can take 1? That's not cool. I cannot take 1. How is that possible? Yeah, I'm kind of 4. 4, 1. 0, 1, 2, no, 1, 2, 3, 4. 4, 1 is nothing because I cannot do. For 2, I have price, which if I give a 2, how can I give a 3? At the 4th position, how can I give a 3? Oh, this is the number. Okay, so 2 shall be impossible. These shall be impossible. Huh? Oh, I want to is right. 1, 2, 2, 2, 2, 2. If I have 2, which I go 1 is 1. If I have 2, right? If I have 2, and then that's 10. That's still correct. 3. So 3, 1 is not right. So I is 3, okay? I is 3. PJ is 1. Oh, the previous color. If the previous has a color, if it doesn't, then I go through. Okay, I see. So, okay, so current I'm at I, right? And then I need to know what's the previous color. And the previous color, I can get it by 2 ways. One way is to check the previous houses, right? So we say, if houses I minus 1, then PJ is definitive. We have PJ equal to this. Okay, so this is saying if the previous, we have a color. Okay, so now the current, if we have a previous color, then you can say PJ is equal to houses minus 1. And we already have 1. So now we just need to check the current. We say if houses I that will actually go to this. Right, we'll go for this, the whole thing. Hold on, let me see. Let's see, so I say we have a previous house, we have a color. Okay, so it's not just one color. So now PJ is one color. So in the current one, if current one we have a color, then we'll compare to the previous. Then once we compare to the previous, whereas PK, there's no more PK if into the previous, right? And then we need a PK as well. Right? PK. Yeah, that's actually exactly the same as this one. So I'm going to say def helper. PJ right, and then we'll say the previous one if it's this, blah blah blah, and then we just say if this, then we say helper houses, that's only one PJ, else the previous is 0, then we need to go through all possible previous color, and then we do this, and previous might not exist. Else, and this is, I'm going to say helper, pj. Okay, so this one pass. Back to the previous one. Okay. Oh man. Alright, I'm gonna copy the answer and then deal with this tomorrow. This is way too hard. Alright, well, look at the solution. We don't even have Python one. Space optimized. Oh. Yeah, this is pretty tough. What did I not do right? I mean, maybe we can still analyze it. How do I analyze this thing? Do I now consider all the conditions? Maybe we'll go minimally? I don't know, I'm just, I mean, right now it's basically I throw everything at it, everything that I can think of DP related. Oh, look at that. Oh, now I feel promising. Now the only barrier is timeout. Ah, Lord help me. Don't time out. Do not. Please do not time out. Oh, God. Please do not time out. Alright, do not time out. Do not. Do not. Come on. Come on. You can do it. You can do it. Oh, it's not right. It's not correct. What? Holy guacamole. Wait, what? Oh, I didn't put the... Yeah, I know why. Answer. I'll put 49. Hmm? What? What? What's this? The hell is this? You're kidding me, right? You're kidding me. What happened? What the hell happened? It's it works on my laptop. It doesn't work on the OJ. Oh, expected -1. What the hell, man? Expected -1. My bad. See, that's what happens. They did too much time. It got confused. Okay. Don't worry. We can figure this out. 4. Yeah, it should be. It should be. But why is this solution? I mean, I can easily just say how do I say? Remove zeros, right? We'll say if len group by list, right? Group by h for h in houses, if this one is larger than target, then return -1. Yeah, so I can, but now the question is why this thing cannot. Like, how is it possible that we do this, right? And it has to be I minus 1 previous j, whatever it is. Has to be pk. If it's not the same, if it's pk plus 1, then I say pk plus 1. So if pk plus 1 is larger, maybe we can just say dpi. So if the pk plus 1 is larger, so this one shall equal to the fourth dict lambda math.inf. I don't know, will this one work? Just kind of reinforce it. I don't know. Nope. Doesn't work. Why? Two, 3, 4. But here is already 5. How could I have? Yeah, something's not right. Let's analyze. 0, 1, 0, 1, 1. First one color. We have how many colors? 5 colors. Okay. So only 3. 1 causes 0. Yeah. Second one. 1. I have 2, 2, 3. That's correct. So far so good. 3 shall be only 3. Right? So 3. I can have a 3. 3 something 3. Or I have a 1 which is previously 3. Yes, this is still correct. 4. Nothing until 4. That can have 1, 2, 3, 4. That's true. Or 2. That's still right. 5. 5 I can have all of them. So 5 I can have 3 states. Or 2 states. That's correct. 3 states is... We can actually have more, right? I have 1, 2, 3, 4. What happened to 5? 1. How is 1 only 3 states? At 4, I have right at 4. It's this situation. If houses, yes, I have a color. So I go here, and now we say pk, which is 4 and 2. right? 4 and 2. Yeah, this is previous I minus 1. This is 4. This is a 4 because that's 4. So PK is 4 or 2. And F houses, current house is nothing. So nothing. So we go here. So for range 1, it's not equal to, and PK plus 1 is 5, smaller or equal to. Where is 5? Oh, 5 on 5. I have 5. No, I don't have 5. What the hell? Should be I equals 5. House is 4, right? 1, 2, 1, 2, 3, 4. And house is 4 is this. So I'll go helper. House is 4. House is 4 give us 4, right? So this is 4. And then DP, I, I. Shoot. Index. Coding issue. My God. Index. Houses index. 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 I mean, we're already at this stage. Might as well just keep pushing. So I'm going to pass I and this. I. Yeah, still not right. Oh, I think we hit all the indices, huh? Yes. I think I got all the I's. Okay. Again, 4 is right. Yes, it's still 5. We have issue with 5. Oh, we have issue with 5. 2, 3, 4, 5. No matter what, even if it's the same, we can have 3, or we can have 3 is possible. 4, 1, 2, 1. 4 is not possible. How you can make a 4? So either the same, the 1, 2, 2 is actually possible, right? 2 is possible. Or 1, 2, 3, 3 is possible. Or 4, 1, 2, 3, 4. Or 5, but I didn't do 5. Oh, because we cannot do 5 and most 4. Also then the 5 is correct, right? We can put it 1. We can have 3. Put a 2, we have 3. Put a 3, if we have 3 here, I have 1, 2, 3. Yes. But why don't we do 4? Remember, 4 we have At 4, we already hit 4. So the most we can have is 2, right? So 4 will be 1, 2, 3, 4. So we can have 4. 4, we can have 4. Yes. But we can also have 2. Once we get this to 4, we can have 2. Because previous we can have 2, so we have 2. You know what? This is actually correct. Because at here is either 4 or 3. Because at least is 2, right? So we have 2. And then we have something else. 1, 2, 3, 4. So either 4 or 2. So if it's 4, then we can only have 4. That's it. If it's a 2, then we can have 2, yeah? Or we can have 3. All the rest will be 3. So this is actually correct. And number 6, position 6. It should be everything is nothing until here. Should have 4 or 3. Yes, 4 or 3. It depends, because the previous one, either 4 or 3, so this one, the previous one has to be, if the previous one is 2, then it becomes 3. If previous is a 5, is a 3, then we'll do 3. If previous is a 3, then I'd be 5, I'd be 4, yeah. So that's that. And this one, the previous is 4, remain 4, but it was 3, will be 4. So this is already the end. 8 would be 4. 9. What the heck? 1, 2, 3, 4, 5, 6, 7, 8, 9. This position has issue. So this position I said, right, 8, 4. We only have 1. And in this position, 9. Okay, let's see the code. And I'm going through. So I say houses, no, previous is no houses. So I go through everything and I see if not, oh, shoot. I see, this is the problem. I should not do that. I shall go through everything. So go through all the colors. Oh my god. So go through everything. If it's nothing, if it is completely nothing, then we're gonna do something, right? But so we'll have something, and then we'll see, and then okay. So we'll go through everything. Hold on, let's not do this. I know what the problem is. Say if dp. Actually, I forgot what that. If dp I minus 1 pj. If it has something, all right? If it's not empty, then we go into it, try to go through all the previous, which makes sense. So that's if dp. Otherwise, right? Otherwise, and then we say has group false, and then if this, then has group has true. Yeah, has neighborhood. Yeah, let's make it more explicit. Has neighborhood, right? And then when we get out, we say if not has neighborhood. If the previous one doesn't have neighborhood, right? If it does not have neighborhood, and we still need to do this. We still need to do this thing. This is like kind of initialization, right? So this will only happen if an I is equal to, I want to say I equal to 1, which means it's the first one. If I'm the first one and I try to find a previous and I have nothing, then I initialize it, right? Else, that means we already can break it. And in this case, we don't even need to check this because this will be considered inside because I'm going through the previous color, right? I'm going through the previous color, and if the previous one is, then only one of them will do. Actually, it would be like this. If this, else break. So I think I can remove this, and we don't need helper then. Let's try this first. Right, this one pass. Okay. Okay, pass everything. Yeah, I'm gonna move this one down. Okay. But I'm gonna add this edge case. We already painted houses form more than target neighborhood. explain what DP is. And then we start. Okay. Pass. Alright, I'm gonna end it right here. It's already 3 hours. I'll see you guys tomorrow. Adios.